Hello, and welcome to the Applied AI News. In this episode, we're diving into AI's transformative impact, from Amazon's massive infrastructure investment to OpenAI's vision for a post-smartphone world. We'll explore how smaller language models are challenging the dominance of larger ones, how AI is augmenting jobs, and practical tools to build your own AI agents. Finally, we'll cover recent advancements in reasoning, context handling, and neural network compression. Let's kick things off with the big picture: how AI is reshaping industries and the future of work. Amazon is making a massive bet on AI, planning to spend roughly $100 billion on AWS infrastructure this year. This is not just about keeping up with Google and Microsoft. It's about anticipating the immense opportunity AI presents. Amazon CEO Andy Jassy believes AI is potentially the biggest technology shift since the internet. Speaking of bold bets, OpenAI aims to replace smartphones with a new AI device, partnering with former Apple designer Johnny Ive. This isn't just another gadget. It's a vision of a future where AI interaction is seamless and intuitive, potentially rendering the current smartphone paradigm obsolete. While the challenge of convincing people to adopt a second device is significant, this venture highlights a future where dedicated AI hardware plays a central role in our lives. While OpenAI looks towards new hardware, Anthropic study provides a data-driven look at AI's impact on the modern workplace. Their analysis, based on millions of conversations with their AI assistant Claude, reveals that AI is primarily augmenting specific tasks, especially in software development and writing, rather than automating entire jobs. This is really important to understand the AI impact on job landscape and retrain in the areas that AI cannot take over. The report also highlights that AI adoption peaks in mid to high salary ranges, suggesting a complex relationship with wages and potential impacts on economic inequalities. This signals a need for businesses and policymakers to prepare for evolving workforce dynamics, including the need for employee training and process redesign. BCG Global's report, From Potential to Profit: Closing the AI Impact Gap, reveals that companies are struggling to translate AI investments into substantial value. The survey highlights an impact gap where companies fail to see ROI on AI investments due to poor integration. The solution, according to BCG, lies in prioritizing key initiatives, prioritizing the question of what to do with the technology and why to do it, adapting core processes, and training employees. This isn't just about the technology. It's about a shift in mindset and managing AI as a comprehensive transformation. Lastly, 1,000 AI NPCs in Minecraft creates a compelling case for the potential of multi-agent collaboration. AI agents develop societies, economies, and cultural nuances spontaneously. The scale and emergent behavior of these agents demonstrate advanced capabilities in multi-agent collaboration. Let's watch a short video on this together.
This is a Minecraft server, but every player here is actually an autonomous AI agent. And they're completely Minecraft agnostic, capable of using other apps and games. Our agents started with nothing and then worked together to collect over 300 items in Minecraft. They set up a market where agents agreed to use gems as a common currency for trading supplies, building an economy. In this case, you might think the merchants would trade the most, but it was actually the priest. Why? He was bribing townsfolk to convert.
Now let's shift gears and look at some of the groundbreaking research happening in AI. A fascinating Nature article demonstrates the potential of autonomous chemical research with large language models. Researchers used GPT-4 to optimize chemical reactions, leveraging past data to iteratively improve yields. The study showed that GPT-4 could effectively reuse information to improve guidance on reactivity, even outperforming standard Bayesian optimization in certain aspects. The agent can even reason about compound reactivity based solely on smile strings. This highlights the potential of LLMs in tackling real-world experimental campaigns and their ability to learn and adapt within a chemical context. What is important is LLMs can be trained to make experimental decisions with little human supervision. Another article challenges the assumption that bigger is always better. Can 1 billion parameters LLM surpass 405 billion parameters LLM? Rethinking compute optimal test time scaling demonstrates that smaller language models can surpass larger ones by optimizing test time computation strategies, or TDS. The compute optimal TDS strategy is highly dependent on the choice of policy model, PRM, and problem difficulty. With compute optimal TDS strategy, extremely small policy models can outperform larger models. For example, a 1 billion parameters LLM can exceed a 405 billion parameters LLM on Math 500. Moreover, on both Math 500 and AME 24, a 0.5 billion parameters LLM outperforms GPT-4o, and a 7 billion parameters LLM beats O1 and DeepSeek R1, while with higher inference efficiency. The implications are significant, suggesting that efficiency and optimized resource utilization are key to unlocking the full potential of LLMs, with an increased focus on building specialized models with unique and highly efficient architectures. Researchers at Metasphere Lab in Paris have achieved breakthroughs in decoding language from the brain using AI. They've successfully decoded sentence production from non-invasive brain recordings, achieving up to 80% character accuracy and reconstructing full sentences. This not only advances our understanding of human communication, but also brings us closer to advanced machine intelligence. Imagine how such technology can enable human-computer interfacing and how it raises the bar for privacy-preserving interactions directly from the brain to the machine. Another team is challenging conventional wisdom with Limo. Less is more for reasoning. Their research demonstrates that complex mathematical reasoning abilities can be effectively elicited with surprisingly few examples, just a little over 800 samples. Limo achieves unprecedented performance in mathematical reasoning, achieving 57.1% accuracy on AIME and 94.8% on Math, improving from previous SFT-based models 6.5% and 59.2% respectively, while only using 1% of the training data required by previous approaches. The study proposes the less is more reasoning hypothesis, Limo hypothesis, in foundation models where domain knowledge has been comprehensively encoded during pre-training. Sophisticated reasoning capabilities can emerge through minimal but precisely orchestrated demonstrations of cognitive processes. Continuing the theme of efficient reasoning, scaling up test time compute with latent reasoning, a recurrent depth approach introduces a novel language model architecture that scales test time computation by implicitly reasoning in latent space. This approach avoids the need for specialized training data or generating more tokens. Instead, it enables the model to reason in an abstract space without direct mapping to specific tokens per thought packet. Furthermore, infinite high-P, extending language model context up to 3 million tokens on a single GPU, tackles the context length limitation in language models. By employing techniques like context pruning and dynamic KV cache offloading, it enables processing of up to 3 million tokens on a single GPU. And finally, Matryoshka quantization proposes a novel multi-scale quantization technique that addresses the challenge of needing multiple quantized models. It allows training and maintaining just one model, which can then be served at different precision levels, improving accuracy for highly compressed models like INT2 by up to 10% compared to standard quantization. Let's get practical. What is an agent? From Hugging Face provides deep explanations on how AI agents tackle task completion by reasoning, planning, and using tools to interact with their environment, offering solutions like advanced virtual assistants and chatbots. Similarly, understanding AI agents through the thought-action observation cycle is another great Hugging Face learning article, explaining how AI agents operate through a thought-action observation cycle, continuously adapting their approach based on feedback to achieve their objectives. OpenR1 Update Number 2 shares that the OpenR1 project creates a large math reasoning dataset and fine-tunes a model, achieving comparable performance to DeepSeek, while also investigating methods for dataset curation and COT length optimization. Finally, Hugging Face is democratizing AI with the release of SmallLM 2. While not a revolutionary model, SmallLM 2 achieves solid advancements through careful data sourcing and methodical training. It performs competitively against similar models like Quint 2.5, 1.5 billion, and Llama 3.22 billion, particularly in specific knowledge and comprehension tasks. This is huge, as the open-source approach, including sharing training data, makes it valuable for smaller tasks on devices with limited resources. This reinforces Hugging Face's commitment to driving AI research and provides more opportunity for our audience to remain hands-on. In summary, today, we've journeyed through a landscape of AI innovations. From Amazon's monumental investment in AI infrastructure to OpenAI's quest to redefine personal devices, we've seen how AI is poised to reshape industries. We've explored how smaller, more efficient models are challenging the dominance of their larger counterparts, and the practical tools enabling us to build AI agents without code. The future of AI is not just about bigger models, but smarter, more efficient systems that augment human capabilities and unlock new possibilities. This is all huge for our audience, as they have new ways to utilize AI and make it more transformative.